All right, let's dive in. Today we're tackling cell-free chromatin particles, CFCHPs for short.
Catchy, right.
Well, the topic itself is pretty fascinating, if not a little creepy.
Oh, absolutely.
We're talking about tiny beats of DNA and protein that get shed from dying cells. And, we're talking billions, even trillions of cells dying every day.
It's true, we're practically swimming in CFCHPs.
Which brings us to this 2024 study from Cell Death Discovery.
A real head-scratcher.
Yeah, it really makes you wonder if these tiny little fragments are causing more trouble than we thought.
Oh, I think they are. Especially when you consider mitochondrial damage, aging, even diseases like cancer.
Okay, so let's break it down. The study itself is pretty dense.
Lots of jargon.
Yeah, but we'll translate. One of the first things that jumped out at me was how easily these CFCHPs can get into healthy cells.
Right. It's kind of alarming how fast it happens.
The researchers took CFCHPs from human blood, added them to mouse cells, and bam.
4 hours later.
They're inside.
It's like that. And what's really cool, they used fluorescent labeling so they could actually see these particles moving into the cells.
So they're just slipping right in. What does that even tell us about the threat level of these CFCHPs? I mean, if they can infiltrate that quickly, what are they doing once they're in there?
Well, that's where things get really interesting. It seems these CFCHPs can actually damage the DNA inside the mitochondria.
The mitochondria.
Yeah, the powerhouses of the cell.
Right. So they're attacking our energy source.
Basically. And they saw all these signs that the mitochondria were in distress. The DNA was damaged. They were becoming fragmented. They couldn't produce energy efficiently.
It's like someone's sabotaging the power grid.
Perfect analogy.
Yeah.
The researchers found higher levels of these markers, like H2AX and PATM. Those indicate DNA damage. And they even found CSCHPs physically stuck to the mitochondria.
Like they latched on, gumming up the works.
Exactly. Probably through some kind of chemical interaction.
I mean, can the cells even fight back against this?
Well, they try. The study showed an increase in mitochondrial mass. So it's like the cells are trying to compensate by making more mitochondria.
More power plants, but they're all wonky.
Exactly. Not a great solution. And to make matters worse, they found CFCHPs actually trigger oxidative stress.
So that's where the real damage comes in.
That's a big part of it. Oxidative stress is basically an imbalance between these harmful free radicals and the antioxidants trying to fight them off.
Like a cellular tug of war.
Exactly. And the CFCHPs are giving the bad guys, those free radicals, a big boost.
And we know oxidative stress is linked to, well, pretty much everything that goes wrong in the body, right? Aging, diseases.
Yep. So this connection to CFCHPs, it's pretty significant.
For sure. But is this just a problem with the CFCHPs already in our bloodstream? Or are we also talking about the cells that are dying within our own bodies?
That is the question, isn't it?
I have a bad feeling about this.
Yeah. So the even more concerning thing is they found CFCHPs released from cells dying, from things like lack of oxygen. They can also trigger this ROS production in healthy cells.
Oh, man. So it's not just an external threat. It's an inside job, too.
Pretty much, which means this could be happening all the time, everywhere in the body.
Yeah, as cells naturally die off. I mean, the sheer number of cells dying daily, are we doomed?
Now, let's not get ahead of ourselves. There's more to unpack here.
Okay. But seriously, if we're constantly producing these tiny little ticking time bombs, what can we even do about it?
Well, about that, there might be some hope on the horizon.
Oh.
Do tell. The researchers actually tested 3 different CFCHP deactivating agents, and the results were pretty interesting.
Okay, I'm all ears. What are these CFCHP busters? Lay it on me.
Well, first up, they tested something called CNPs. It stands for Pullulan Histone Antibody Nanoconjugates.
Try saying that 3 times fast.
Right. Basically, they're these tiny particles coated with antibodies that are specifically designed to target histones. And since histones are like a key component of CFCHPs,
Okay.
these CNPs act like tiny magnets. They grab onto the histones and neutralize the CFCHPs before they can even get into healthy cells.
So it's like a security system intercepting the bad guys before they can do any damage.
Exactly. And they found that CNPs were really effective at reducing the production of those harmful ROS we talked about earlier.
ROS, right? Those reactive oxygen species that are causing all the trouble.
Yep, those guys. What's really promising about this approach is that it's very targeted. It's not just indiscriminately wiping out everything in its path.
Right. Targeted therapies are always exciting because, fewer side effects, hopefully.
Exactly. Okay, so next they tested DNase I.
DNase I. All right, what is that?
It's an enzyme that breaks down DNA.
So like a molecular shredder.
Pretty much. It just goes in and chops up the CXCHP's DNA.
Dismantling the weapon. I like it. But did it work?
Yeah, they saw a significant reduction in ROS production with DNase I2. It really kind of confirms that CFCHPs are the bad guys here.
Okay, 2 down, 1 to go. This last one, I gotta say, I'm a little skeptical about.
Oh, why is that?
Well, it involves resveratrol. You know, that stuff in red wine.
Ah, I see where you're going with this.
I mean, part of me wants to believe that a glass of red wine could be the secret to fighting off these CFCHPs, but...
It does sound a little too good to be true.
Right. But tell me more. What did they do with the resveratrol?
So they combined it with copper, created this thing called R+Cu, and here's the interesting part.
Right.
Resveratrol on its own, it's an antioxidant, which you'd think would be a good thing, right?
Right, fighting those free radicals.
But when you pair resveratrol with copper, it flips and becomes a pro-oxidant.
Pro-oxidant, meaning what? It creates free radicals.
Yeah, but it's a bit of a fire with fire strategy.
Okay, now I'm really confused. Aren't free radicals the enemy here?
They are. But the free radicals generated by R+Cu, they specifically target and degrade the DNA in the CFCHPs.
Ah, so it's like a targeted missile strike, instead of just carpet bombing the entire cell.
Exactly. And what's really intriguing about R+Cu is that both resveratrol and copper are naturally occurring. You know, resveratrol in plants. Copper is an essential mineral.
So potentially, this could be a safe and, relatively accessible treatment option.
That's the hope. Of course, it's early days. We need more research.
Right, we're not going to start chugging red wine and copper supplements just yet.
Definitely not. But the early results are promising. And the fact that they found 3 completely different approaches that seem to work, that's a good sign.
It is. So even if we're constantly producing these CFCHPs, it's not like we're completely powerless against them.
Not at all. This research gives us a few potential weapons to fight back.
I like the sound of that. But let's be real, this is all still very early research. We can't get ahead of ourselves and start making promises about cures or anything like that.
Definitely not. But it's exciting to think about the possibilities.
For sure. Okay, so we've got these potential culprits, the CFCHPs, and we've got a few promising leads on how to stop them. But can we take a step back and look at the bigger picture here? This research seems to be kind of challenging our traditional views on aging and disease, doesn't it?
It does. We tend to focus on things like, genetics and lifestyle factors. But this study suggests that these tiny particles from dying cells, they could be a much bigger piece of the puzzle than we ever imagined.
It's like we've uncovered this whole new dimension of cellular activity.
Right. It adds another layer of complexity to our understanding of how our bodies work, and it opens up a whole new realm of possibilities for therapies.
Instead of just treating the symptoms, maybe we can start preventing the damage in the first place.
Exactly. What if we could neutralize these CFCHPs before they even have a chance to wreak havoc?
That would be a game changer. Okay, so where do we go from here? What's next in our CFCHP adventure?
Well, in the final part of our deep dive, we're going to explore some specific diseases that might be linked to CFCHP-induced damage.
Ooh, getting specific.
And we'll delve deeper into the potential therapeutic applications of those CFCHP deactivating agents we talked about.
All right, I'm ready. Let's do it. All right, so we've spent the last 2 parts of this deep dive really getting into the nitty-gritty of CFCHPs, all this research, their potential role in aging and disease. I'm ready to kind of connect the dots here. Are there any specific diseases where CFCHPs might be especially impactful?
Well, the study itself didn't really dive into specific diseases, but, taking a step back, knowing what we know about CFCHPs causing all this mitochondrial dysfunction, oxidative stress, you can start to see some potential connections, like take neurodegenerative diseases.
Oh, okay, like Alzheimer's, Parkinson's, that sort of thing.
Exactly. Both of those are linked to, well, the same cellular problems that CFCHPs seem to be causing.
So is it possible that CFCHPs are actually like making things worse, exacerbating the damage that's already happening in those conditions?
Yeah, it's a hypothesis worth exploring, for sure. And it raises a really interesting question. What if we could target and neutralize CFCHPs specifically in the brains of people with these diseases?
Oh, wow.
Could we slow down the progression, maybe even reverse some of the damage? I mean, it's a long shot, but...
It would be incredible. What other areas could benefit from this, from CFCHP research?
Well, I mean, the potential applications are huge, right? Oxidative stress is a factor in so many diseases, cardiovascular disease, diabetes, even cancer. It's not a stretch to think that CFCHPs might be playing a role there, too.
So we've got these potential culprits, the CFCHPs. We've got a few promising leads on how to stop them. The CMPs, The DNase I, that resveratrol copper combo. Let's talk about how these could actually be used, in a clinical setting.
Right. Of course, got to remember this research is still early. We're a long way from having any CFCHP targeting therapies ready for, actual patients. But it's exciting to think about, right?
Yeah, let's speculate a little. What are some potential ways we could use these agents?
Well, with the CMPs, those antibody-coated nanoparticles, one idea is to use them to mop up excess CFCHPs in the bloodstream before they can even reach healthy cells.
Okay, so kind of a preventative measure.
Exactly. And because they're so specific, targeting just the histones, part of the CFCHPs, you'd hope there'd be minimal side effects.
Specificity is always good when you're talking about therapies. What about DNase I? How could we use that therapeutically?
Well, one possibility is to deliver DNASI directly to the areas where the CSCHPs are causing the most damage. So, for example, in neurodegenerative diseases, you can maybe inject DNASI into the cerebrospinal fluid, and it would break down the CFCHPs, hopefully protect those brain cells.
It's like sending in a specialized cleanup crew.
Right. But of course, there are challenges with direct delivery, right? Getting it to the right place, making sure it doesn't cause any harm.
Yeah, benefits and risks. Always got to weigh those. Okay, what about that resveratrol and copper combo? Could that be a practical treatment?
Potentially, right. I mean, resveratrol is already widely available. It's a supplement.
Hmm?
Copper, essential mineral, we get it through our diet. So theoretically, you could develop a safe, effective treatment.
I'm already seeing the headlines. Red wine compound holds key to longer life.
Right. But seriously, if something that simple could help neutralize CFCHPs, that'd be huge.
It would. Of course, more research is needed. Figure out the right dosage, make sure there are no, long-term risks.
Right, safety first. But overall, this research has opened up some really, really exciting avenues.
It has. It's a good reminder that, scientific breakthroughs can come from the most unexpected places.
Absolutely. And this is just the beginning, right? As more scientists get into this, we're likely to uncover even more ways to target CFCHPs.
Well, this has been quite a journey. I feel like we've gone from, 0 to 60 on CFCHPs, started with these tiny, often overlooked particles from dying cells, learned how they could be major players in aging and disease. And while there are still a lot of unknowns, the potential for future therapies is huge.
Yeah, it really is groundbreaking research. It challenges how we think about aging, how diseases develop, and it's a great example of just how much we still don't know about our own bodies.
It makes you wonder what other hidden processes are happening right now that we're totally oblivious to. There's so much more to explore, but for now, we'll leave you with this thought. If these tiny particles from dying cells can have such a huge impact on our health, what does that say about the delicate balance between life and death within our bodies? Something to ponder. Thanks for joining us on this deep dive.